Hey there, welcome back to the channel. My name is Chris, and today I want to talk about Modbus devices. Specifically, let's talk about how we query Modbus devices or program with Modbus from a C# application. So let's take a look at an example of a Modbus device. I have here a thermostat. Now, Modbus devices come in a very wide array of things. PLCs, sensors, lots of things. So this is just a representative example. The way Modbus works is these devices have what are called registers. Basically, think of it as an array of 2-byte, values that you're going to read and write to. Now, Modbus does have coils and inputs and some other things, but for registers, they're generally speaking a bunch of 2-byte values, and those values might be read-only or read-write. We're going to talk about what's called a holding register, which is read-write, and they're all 2-byte. Other types of values are a very similar way of accessing, but just for simplicity, we're going to talk about the holding registers because they actually tend to be the most common thing used. Now, if we take a look at this device, this is Modbus RTU, which is a serial that sits on RS-45. What that means functionally is that you can have multiple devices that are hooked onto the same serial bus. So you can have 2 serial lines that run across, say, a building or a plant floor or whatever, and you can have multiple devices on that. Each one of the devices has a unique address. It's a byte address, so 8 bits. So you're going to talk to this device with a given address, and then you're going to ask it for data from a specific register or write to a specific register. Now, every device has a different set of registers. Let's go take a look at the ones for this device here. So I have this CSV that I got from the manufacturer that basically lists all of the registers. You can see that the serial number, interestingly, it's a 4-byte value here, 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 and here, right? So it really doesn't make any sense that it says it's a 4-byte value because this is 2 bytes and this is 2. So this is probably the serial number low and serial number high, something along those lines. The point here is that we've got a whole bunch of different values, and this thermostat has, the ability to have internal sensors, external sensors. It's got tables for lookups. It's got PID functions. It's got away. It's got occupied. It's got day. It has night. Lots and lots of things, right? But it has the usual things like what is the current temperature? So let's take a look at how we would get values from these. Now, it's worth pointing out at this point that these values, like I said, are 2-byte values in a register, but maybe the value that you're looking for spans multiple bytes, like that serial number at the beginning. So it might be a 4-byte value stored in 2-byte registers. You'd have to read 2 registers and compile it into that single value. The values might be integers, might be IEEE floats. It might be stored big endian. It might be stored little endian. There are a lot of different options as well. So we have a lot of variables here. First, we have the device itself has a communication bus. In this case, it's serial, but this also works over TCP. It's a little bit different on the wire, but we have different communication modes. The device itself has an address on the bus, so we've got a Modbus address. Then we have registers, and we have input registers, we've got holding registers, and the command to read them, while very, very similar, is slightly different. We then have all of the values that might be stored, big endian, little endian, integer, float, things like that. So we've got that variability. So there's a ton of variation that can happen here. So what we'd want is we would want some sort of a library that makes this simpler for us, something that takes away and abstracts a lot of that stuff so that From a programming perspective, we say, hey, I know that this device at this address, this register at 121 that we have listed, is the temperature. Go ahead and read it back. In this case, I know that that temperature also is an integer, but it's in tenths of a degree, so I need to scale it by 0.1 anyway. So let's go take a look at the library that I typically use for this and how we would program for some, simple device like this. So let's just create a console application. This will give us a base from which we can add the library and do some code to show how we can use this device. I'll just call this application thermostat test because I'm unoriginal. Let's just make it a .NET 8 application. So the first thing we're going to do is we're going to bring in a library, and we're going to bring in Meadow.Modbus. You'll notice here that it is 1804 beta. By the time that you watch this, it's likely that it will be a released feature, but right now I'm going to be using some beta features that I just added this week to this library. It's worth pointing out that I am biased toward this library because, well, I wrote it. That said, this is probably about the fourth Modbus library that I've written over the past 2 decades based on things that I've learned from in-field use and from writing libraries and finding features that I don't have or things that I don't like the way they work. So let's go take a look and see how I would use this. First, what we're going to need is we're going to have to consume the device. Modbus is a little bit counterintuitive because the device is a server and we are the client to that server. So we want to create a client that connects to that device. I'm going to be using the Modbus RTU client. RTU for Modbus is serial. It stands for Remote Terminal Unit, but it is the 485 version. First parameter of the client is this I serial port. It's not quite as simple as just passing a system I/O serial port in, because this is cross-platform and works even on microcontrollers, and the .NET serial port does not work cross-platform. So we have to make this Meadow hardware I serial port interface. So let's actually create that first. In this case, we'll be using COM3, which is this USB to 485 serial port converter. I will put a link down in the description to the one that I'm using, but it is an FTDI chip-based USB to 485 converter. If you are looking for one of these, make sure you get FTDI. There are some that have a prolific chipset, but my experience is the ones with the prolific chipset are often counterfeit chips in them, and when you plug them into like a Windows 11 machine, they will not work. So we create this serial port shim, which gives us that interface that we need, and then we'll pass this into the client. And we don't need to worry about anything else. So now we have an RTU client that we can use to communicate with any Modbus device on the bus. So if I had multiple thermostats, multiple whatever sensors, I could use this single client to communicate with everything that is connected to COM3. Just for good programming practices, I'm not going to put all of the code for communicating with this one device into our program. Instead, what I'm going to do is create a device for this tstat8. So this will be our abstraction of that thermostat. And to communicate with it, we know that we need a Modbus client. And let's break this out into another file so it's a little bit easier to read. So now we have this thermostat class, and the next step is to add some properties that map to registers on the device and then populate those properties with data from the device. I'm going to show you how easy that is to do. So for example, let's take temperature. That's the first thing we want. We'll have a temperature property. The question is, how do we get the temperature from that device over to this temperature property? The easiest way for a device like this is to actually use a base class called Modbus polled device. Now, it's important to understand that Modbus devices don't have interrupts. They don't broadcast any data to us. They only work by us querying them. So in order to read this temperature, to read this value, we have to poll the device. So if we create this Modbus polled device or derive from it, this will give us a bunch of things like the communication to the device, how to read registers, and it gives us a timer, in fact, on how to do that. You can see that we already have an error here because we need to pass to the base our client, and we need to pass in the address. And in fact, let's add the address here. This is the Modbus address, so the device address on the bus, not the address of any of the registers. So we'll be absolutely clear with that, and we'll pass that in, and we can change the refresh period. So let's say we want to update the temperature, have it read from the device once a second. And since this thermostat is serial only, we might as well just use the RTU client. Now let's take a look at the power of this Modbus polled device base class. We know that our register, and let's just start a register map here. Registers are a U-short value. And I know that that one is at 121 based on this map. So if I want to go read from register 121, and I know that it is a single register, you can see 122 is an analog input, so it's a single register. So what I can do here is I can map, it is a holding register, and I want to map it to a property. It starts at temperature register, and if I spell temperature correctly, that will help. We know that it is a single register, and I want to map this to this property. And we've got a couple of options here. We can either pass in a conversion function, or I can provide things like a scale, offset, and the source format, which is whether it's big endian, little endian, integer, or IEEE float. So it will do any of those conversions for us. Now we know that we want to scale it by 0.10. Now I know that from using this device. So if I read the temperature and it's say 72.5 degrees in this room, I'm going to get back a value that is 725 from that device. I also know that the source format for this is a little endian integer. So now I can go out and map that, which will read the temperature. And because I created it with a refresh interval of 1 second, every 1 second it should update that temperature. And that's all there is to it. I have now created a Modbus device driver that is going to read this register and put it into this property once every second, scaling the value that it reads from the register by 0.10. In fact, it's converting it from the integer or the U short that it reads into a float in that translation as well. So let's just verify that that's exactly what it does. So I've created this client. I'm going to pass it in. So I have the device sitting over here. If I power cycle it, you will see the Modbus address come up on it. So if you caught that, it says it's address 201. So we're just going to read in an infinite loop here. So now let's run this, and we should get a temperature in the console that matches what we see over on the device. 67.9 on the device. And you can see I'm getting back zeros. And the reason for that is I forgot to tell it to start updating. And now let's try it again. And what? And how about we open the serial port now? So you can see we got a couple of zeros because we were outputting here before it did its read at all. But you can see we've got 67.9 here, and that is what matches the display. Now, the temperature in here isn't changing, so it's not obvious that it's reading a new value periodically. So let's go ahead and grab a value. There it just did change, but let's grab a value that we can control a little bit better. If you take a look at the thermostat, down here, it says 66. That is our set point. So that's when it's supposed to either heat or cool. And I can use these buttons to adjust that. Right. So it would be nice if we could just read the set point off of the thermostat and display that as well. So if we come over here, we want to map that. So we need to know the register address for the set point. And if we come over here, I actually have a cheat sheet that tells me where it is. The set point for the occupied daytime. For the occupied daytime, again, this thing has day, night, occupied, and unoccupied. So it has a bunch of different ones. But 345 is the one that we're currently set on right now. So we'll create this set point property. We have a register for it. And so we're going to just map this as well. Come back over to our application and run it again. So you can see our set point now, it says 71. If I adjust it, the output goes down in our output. If you look right up here in the corner of the device, you can see arrows for up and down. Those are the Modbus communication indicators. So it is sending and receiving. So that's all there is to it to creating a Modbus device driver. We can go out, map these registers to properties, and it will read and write them. There are a couple other features that are worth pointing out when you get into a device that maybe is a little bit more complex than just a simple single register read type scenario. So let's take a look at this set point. That's a good example. This is one that we can read or write on the device. The way I have it now is this does a map to this property. So periodically, every 1 second, it writes to this set point. So if in my code I wanted to set that, I could do a couple of things. I could have a separate method. Let's call it write, just because that set looks weird. I could do something like this. And then I would have to do the scaling of that because this takes in, again, U short. So I have to take that value, multiply it by 10, and then truncate it to a U short. So I could write the set point that way. Seems a little bit strange and unwieldy to have both a property and a method, one for reading and writing. So we could go about it a little bit differently. We could instead have a backing field, right? And now When I set the property, it's going to write the value to that register. And since we're polling once a second, it's going to go back and try to read it. Now, the challenge here is we would end up in effectively an infinite loop. This would read the property for the set point and then call this property to write it again. And we'd end up in this loop, which is not something we want. But what we can do, and I guess we have to create that field, what we can do is instead of mapping it to a property, we can map it to a field like that. So now on that poll period once a second, instead of writing to the property, it's going to write to this backing field. So we'll write to this field, and then if you do a get, you'll get the same thing. So if I run it again, and I really should put a delay there at the beginning to give it time to go read the data before we start outputting. But you can see again, that set point is there. And as I adjust it, you can see the set point went up. So it is reading that register, mapping it to this backing field, and then the property is reading that field. So if you have something that's read-write, it's better to use a map to a field than a property. The last thing I'd like to show you is what if I've got a field that is more than 1 byte long and maybe it is not a standard format. A good example here on this is the clock. Now if we go find the clock on this device, you can see it starts here at 4:10 and it's got year, month, week, day, hours, minutes, seconds, and these are all integers on each one. So this isn't like a standard Unix formatted time or anything like that. We just have a different integer for each one of these. So how do we turn this into something that is a date time in .NET? Again, this library makes it pretty easy. So let's add a value. So let's add a property. Just for completeness, I am going to make that private, because we don't want somebody to try to set it externally. But now let's map this. Now we're going to, again, map a holding register to a property. We know that that clock starts at 4:10. Now let's take a look at the register count. We know that we want to read in 1, 2, 3, 4, 5, 6, 7 registers. So 14 bytes, 7 registers. And we are going to write that to our clock property. And now the fun part is, how do we get those 7 bytes into a date time? We're going to provide a conversion function, and we could just do a lambda here, but I will do it to a separate method just because it'll make it a little bit easier to read. And you can see it's going to pass in uShort array, so the data that it needs to convert, and then you have to pass back out an object. Now that object has to match the type of the property. So that's our map here. And now let's return a converted date time. We're going to use the overload here that takes year, month, day, hour, minute, second. So we have year, month. Now we don't need this week, so we'll be year, month, day, hour, minute, second. And this is at element 0 from the data that passes in, because it's going to start here. Now we're going to skip week. And so that converts this data into a date time. And now let's go over here and output the clock value. And in fact, let's do that initial delay to give it time to read. But let's start that and take a look at what that gets us. So you can see that the clock is incrementing 1 second. Now, it is set for 2029. That's simply the fact that the clock on the device is set wrong. You can see that the clock is ticking over there, and we are coming in and reading that. So if I set a breakpoint here, you can see that the data that comes in, and let's change that. So it's 2029, 10/2/23, so October 2nd of 23, and it's 5:58-ish. October 23rd, 29, 5:58. So here we go. I have in roughly 60 lines of code, and not even compact code, created a device driver for a Modbus RTU device that reads, well, I'd say 3, but it reads something like 9 registers, because we're reading 7 here, I think. Reads 9 registers and updates 3 .NET properties that you can then use in your application very easily. So really that's it. I just wanted to cover some of the new features with the Modbus Polled device, which I added here in the last week, and just how easy it is to use Modbus devices using the Meadow.Modbus library. Again, I will put a link down in the description over to this. This is fully open source. You can use it on anything. I'm just using it on Windows. You can see that all I did was pulled in a single library that brings it in. This will work on Linux. I actually use it on Raspberry Pi quite a lot. It will work on Meadow microcontroller devices, so it is a cross-platform library. You can also communicate with Modbus TCP devices the exact same way. The only difference there is when you create the client, you would use a Modbus TCP client instead of RTU and provide an IP address instead of a serial port. If you've got any questions or comments, or if there's any other type of content or, topics that you would like me to cover, go ahead and leave a comment down below. Otherwise, thanks for watching.